Here we have a problem of ordinary differential equation second order. Here we have y double prime minus 2y prime minus 3y equal to 0 with initial value y0 is equal to 0 and y prime 0 is equal to 1. So how to solve this differential equation? First, we assume or we let y is equal to e power of rt. This is exponential function. And if we have y is equal to e power of rt, meaning that we have y prime is equal to r times e power of rt. And absolutely we have y double prime is equal to r squared times e power rt. And then if we go back to our problem, y prime minus 2y prime minus 3 times of y is equal to 0, we can write by using this assumption, we can write this problem into e power of rt, r squared, y double prime, minus 2r e power of rt minus 3 times of e power of rt is equal to 0. Here we have e power of rt in every terms. So it's meaning that we have e power r of t, and we can write inside r squared minus 2 times of r minus 3 is equal to 0. From this equality, we absolutely know that e power r over t is not equal to 0, meaning that it have to or it should be 0. So we only try to solve this equation. R squared minus 2r minus 3 is equal to 0, and we have r minus 3 r plus 1 is equal to 0. So we have r1 equal to minus 1, r2 is equal to 3. And after that, as we know, for second order differential equation, we have a general solution. General solution can be written as y is equal to c1 times e power of rt r1t plus c2 e r2 times t. We can substitute this r1 and this one r2 into this form, but we need c1 and c2. This is how initial value apply. We write down first this one, so we have yt is equal to c1 times e r1, it's meaning like minus t, plus c2 e power of 3 times of t. If we substitute t is equal to 0, it's meaning that we have here y0 is equal to c1 e power of minus 0, it's meaning that 1 plus c2 also 1. This is equal to 0 because y0 is equal to 0. From this equation equality, we have c1 is equal to minus c2. We call as a. Okay, and then we substitute y prime 0 is equal to 1. If we have y is equal to this one, so meaning that we have y prime of t is equal to minus c1 e minus t plus 3 c2 e t. Okay, if we substitute time is equal to 0, meaning that y prime 0 is equal to minus c1 times 1 plus 3 times c2 times also 1. And y prime of 0 is equal to 1, so we can write here equal to 1. By using a substitute into y prime of 0, we can write this one minus c1 is equal to c2 minus c2 plus 3 times c2 is equal to 1. This means that we will have c2 is equal to 1/4, and automatically we will have c1 minus 1/4. So our solution is y of t is equal to minus 1/4 e power of minus t and plus 1/4 e power of 3 times of t. That's all.